Hi, my name is Aftab from the Rainmakers team, and our hack is called OBS mapping using natural language processing. The medical industry today uses multiple code standards such as ICD-9, ICD-10, SNOMED, LOINC, and the list just goes on. However, GE records patient observation data in a GE proprietary terminology called observation codes, or OBS codes in short. As more and more new codes come in, our OBS codes at GE need to be able to map to one of these codes. The problem, however, is that there's no such one-to-one mapping between these codes. For example, the OBS description for a code may be occasional smoker, but the equivalent SNOMED code could be something like smokes tobacco on some days. Meet Joanne. Joanne works in the mapping department at GE and is a professional coder. When she sees the description occasional smoker in the OBS dataset, she looks through all the descriptions in the SNOMED dataset and eventually stumbles upon a code that says smokes tobacco on some days. She immediately realizes that these mean the same and can be mapped to each other. For a computer, however, it's not as obvious because these two descriptions do not have a lot of words in common with each other. But there's only so many codes that can be mapped in a manual manner, and eventually we would need some kind of intelligent framework that can do this and help Joanne. Not to mention that this approach is also prone to human error, does not scale well, it's a tedious process and can be cumbersome, and it also produces variable output depending on the domain knowledge of the human performing the mapping. Now that is where we come in. This is our paper submission for the ACL 2017 NLP conference, and we shall use examples from here to explain our approaches. Our first approach is to start with a bag of words model. It basically tokenizes the words in the two descriptions and finds a number of words in common between the two divided by the total number of words in the two descriptions. So considering this example, the number of words in common between the two is 3, which is blood pressure and systolic, and the total number of words across the two is 5. So the Jaccard similarity would be 3 by 5 or 60%. Similarly, we find the Jaccard similarity for all codes in the LOINC code set and maps based on the one that shows the highest similarity. Well, this is a good baseline approach. The problems are pretty obvious. That what if two descriptions are related to each other but may not use the exact same word but synonyms of words? This is where NLP comes in. Let's look at these two descriptions that are already mapped to be similar to each other by a human. But just by first look alone, these two descriptions do not look very similar to each other. So we follow a three-step process to understand the relationship between the words in the two descriptions. Step 1 is to tokenize the words and remove any stop words such as and the and so on, which do not add any extra meaning. So the word and gets removed. In the next step, we apply a Porter stemmer to get to the root of the words. So the words dietary gets replaced by diet and counseling gets replaced by counsel. The next step is to remove words common to both descriptions because since they're already present in both of the descriptions, we cannot establish a relationship between the two. So the word diet gets removed from both of the descriptions. This already puts us in a better state where we know that the word counsel is related to education, to guidance, to procedure, and to management. We then put in some research effort and found out about the word associations network, which given a word tells you the words that it's closely correlated to. So let's search for the word counsel, and it tells us that it's related to all of these words. Luckily, this page is scriptable, and just by looking at substring patterns, we wrote a script to find the words that given a word it's closely related to. Now let's see how we can augment this understanding to improve our mapping process. Say we have a new OBS code whose description is smoking patient counseling. And say we are given two options from SNOMED and we want to find the word that this should map to. Both of these have the word smoking, so we need to look further. Also, none of these descriptions have any of the words from the OBS code in common. But we know that counseling is linked to the words education and procedure, and so this OBS code has to be more closely related to the SNOMED code on the first row as opposed to one on the second row. This is a web interface that when given an OBS code, finds the closest code from the standard code set that it maps to. The 5 OBS codes you see on the left are the frequent searches, so I'll go ahead and pick one of those. For this OBS code with this description, it finds this SNOMED code to be the most closely mappable. Although we do not see any exact correlation between the two descriptions in terms of words, we still find that there's a correlation based on the learning that we describe. For example, the word eye is related to the word retina, the word exam is related to examination, and the word results is related to procedure, all of which are found in the equivalent SNOMED code. And that's how it deciphers this SNOMED code to be the most closely mappable for this given ops code. As part of the implementation, we also want to mention that this project requires a lot of data munging and pre-processing, and we went ahead and used the power of the cloud to do this. So this interface that you see here is the Azure ML, which is the Microsoft Azure Machine Learning Studio. And you can go ahead and drag and drop your data sets, execute R scripts, export the data, and convert them to CSV files. And finally, we can save it on a machine as a completed CSV file while using the power of processing from the cloud.